Welcome to day 17 of our RHCE training, Odo, one day, one video. And I am Alok Srivastava. So this is our first class from the third module of RHCE, or we call it SA3. And the objectives of the day are, we are going to understand about IPv6, the benefits, the features, and then we will be seeing how to configure or assign a IPv6 address to my RHEL 7 machine. So this is one of the exam objective also, to assign the IPv6 address to your RHEL 7 machine. So before we jump onto the like assigning the IPs, we need to understand what is IPv6, why we need it, and what are the features, and then we will proceed further. So IPv6 is the new protocol to meet the requirement of the future internet, or we call it internet version 2. Yes, you have heard it right, even the internet has got versions. So IPv6 is actually designed to meet the requirement for internet version 2. So internet version 2, you can think of it is that a lot of devices, not only the machines, not only the computers or the laptops, your phones, your household items, your locks, your fridge, refrigerators, your TVs, everything is connected to the internet. So you can think it of as internet version 2. And IPv6 is a, you can say, a upgrade of IPv4, which works on network layer 3. Right. So, but why I need IPv6? IPv4 is working properly. Why should I need? So IPv4 is a good, robust routing protocol. But IPv4 was designed in early 80s. And since 80s, it didn't get any upgrade or facelift. And we had learned it in our previous classes that IPv4 is a 32-bit address. So 32-bit address, it offers me around 4.2 billion IP addresses. So at that time, if you see the internet growth is like, we never expected that the internet will grow in such a huge manner. So at that time, when the internet was growing, not that steep curve, before that steep curve, it was considered that IPv4 is more than enough at that time. So the major reasons which played a key role in the birth of IPv6 are: number one, as the picture is showing you, internet growth, unexpected. Second, using the NAT. You know that network address translation, we divide actually what the NAT has done. It has actually made the internet discontiguous. The continuity was broken as the networks were divided into two parts: the private network using the private IPs, and then the public networks using the public IPs. So there is a discontinuity in the internet, as it's very clearly shown from the picture. There is one segment which is the private one, then we have got another segment which is the public one. So we will be requiring some NAT configuration or the routers therein. So it breaks the continuity of the internet. Another reason was no security features in IPv4. There are no security features. Another is, there is not much for the quality of service. That means I cannot prioritize my data. I cannot do that. Next reason is, okay, fine, IPv4 clients can be configured manually. That means the static IP addresses, or IPv4 clients can be configured to use some address configuration mechanism like DSCP. So in case the DSCP is down, this is a problem then. So there is no way in which a device can be configured to have a globally unique address. A globally unique address. So these are some of the reasons which give the birth to IPv6. So after IPv4, we have got IPv6. Oh my God! where is IPv5 and where are version 1, 2, 3. If you see this picture now, which is right there on the screen, till date we have only one version, IP version 4. So version 0 to 3 were actually used when the IP was still in development or testing phase. So they never used those versions. Similarly, IP version 5 was used while experimenting with the stream protocol for the internet. So that is why it is not used. So now we have got IPv6. So that's why we don't see IP version 1, 2, 3 and 5, which is very much clear from this picture here. Okay, now let's come on to the features. We have understood the history, some drawbacks, the features. So IPv6, number one thing, it's very interesting that IPv6 is not designed to be backward compatible. It is not at all designed to be backward compatible with IPv4. We just keep the basic functionality of IPv4. It just kept the basic functionality of IPv4, then rest of it is totally redesigned, revamped. It's like customizing your Harley Davidson from the scratch. Yeah. So the features are larger address space. So IPv4 was a 32-bit address, whereas IPv6 is a 128-bit address, 4 times more address space. So as per the estimate, we can have 1564 addresses in per square meter of this earth using IPv6. 1564 IP addresses in per square meter of the earth. That's a huge space, huge scalability. Second is, which is very important, is simplified header. In IPv4, they have cluttered the header with unnecessary information. The information which might not be, might not be required at this time. So what they have done, they have removed the unnecessary information and the options from the header to the end. They have removed it, and the header of the IPv6 is only twice the size of the IPv4. You can imagine this. The IPv6 address space is 4 times of IPv4, but the header is only twice. So you can imagine that they have really cut down on the header part. Another reason is very interesting, is end-to-end connectivity. I don't require NAT. With IPv6, I don't require NAT. So the discontinuity in the internet of private IPs and public IP, it's gone now. Every host can directly reach to the other host on the internet. Yes, of course, the firewall should allow it, but every host can reach to the other host. I don't need a private IPs or public IPs, nothing like that. Another feature is auto configuration. No DSCP required. One more reason, or the feature you can say, is the faster routing. Why faster routing? In IPv6, the routing information is stored in the first part of the header. So that makes my routing decisions to be taken much faster by the router. And the sixth feature of the IPv6 is IPsec, as I have told you. It creates an end-to-end tunnel between the source and the target. Though it is optional, but that makes it more secure. Another very interesting reason is no broadcast. If you know the IPv4, then while configuring the client with the DSCP, the client need to broadcast. So in IPv6, there is no broadcast. It uses only the multicast to talk to or to reach the multiple hosts or the machines. Eighth feature, which is new and very interesting, is Anycast support. It's a new feature. So what happens is that several hosts on the internet, they are assigned the same IP address. Imagine this, couple of machines or routers on the internet have got same IP. So that is known as the Anycast address. and then the router. So it is normally used for the routing purposes. So routers, while routing, they send the packet to the nearest host. So here is a complete description or a comparison of unicast, multicast, anycast and broadcast. I hope the picture is very clear to you. You can see in unicast one-to-one communication, in multicast one-to-many, broadcast everyone, and anycast I've got certain machines with the same address, but the router is talking to the nearest one. That is the anycast. So these are the features that makes IPv6 much better than IPv4. Now, the next part is, before we jump onto the configuration, we need to understand the IPv6 addressing. How the IPv6 addressing is done. How can I read the IPv6 addressing? So there are certain rules. So let's learn about IPv6 addresses, because it is very important to understand how the IPv address structure works. So as you can see it on the screen, a IPv6 address is made of 128 bits divided into 8 16-bit block. So if I convert each block into like the 4-digit hexadecimal numbers, they are separated by colons and by the symbol colon. So I'm giving you a very simple example which is right there on the screen. So let's see, this is a 128-bit IPv6 address in binary, and you can see it is divided into 8 16-bit blocks, 3, 3 and 2. Each block need to be converted into hexadecimal separated by a symbol colon. So when I convert it, I got this value 2001 colon 4 times 0 3238 DFE 0063 4 times 0 then colon 4 times 0 then FEFB. Now, but there's a long number. It's very difficult to remember this. So even after converting it into hexadecimal, it's very long. Impossible to understand, impossible to remember. So there are certain rules which will shorten this IPv6 address. Rule number 1, discard leading zeros. If you see in block number 5, you see here in block number 5, that is 0063. So leading zeros can be removed. So that means the block becomes 63 right there on the screen. So leading zeros should be discarded. Rule number 2, if 2 or more blocks contain consecutive zeros, omit them all and replace it with a colon symbol, 2 times colon, like column number 6 and 7. They have got all zeros. So we can replace all zeros with 2 times colon. So that makes my IPv6 address to a much smaller one, that is 2001 colon 0000. Then again I can remove this block also. So the second block can also be removed. So consecutive blocks can be replaced by only once. So it can be done only once. So if there are still more zeros, means I can remove 2 blocks having zeros only once. I cannot remove the second block entirely. So I had to replace it with a single zero. So now this is the IP address 2001 colon 0, because I cannot remove it entirely as I had already removed the 2 blocks. Then 3238 DFE1 colon 63 colon means 2 times 2 blocks removed and replaced with the colons, and FEFB. This is how the addressing works. So you need to remember these rules. These rules are very important. So once we have understood all this about IPv6, we can proceed on to assigning our machines a IPv6 address. So let's do that. So the next job is to assign the IPv6 addresses. So before we jump into assigning the IPs, we need to understand the same concept of IPv4, that how the network IDs and the host IDs are identified in IPv6. So let's understand IPv6 network and host IDs of the unicast addresses, IPv6 unicast addresses. So as you can see it on the screen, so IPv6 unicast address, as we'll be focusing on the unicast address only. So the first 64 bits, as you can see it on the screen, first 64 bits are for the network ID and the next 64 bits are for the host ID. And network ID is administratively assigned and the host IDs can be configured manually. You are free to choose your host IDs, or even your host IDs can be configured to be auto-configured using your randomly generated numbers using DHCP version 6, or you might be using extended unique identifier, or we call it EUI64 format. So right there on the screen. Now once we have understood the basic address, so it's same if you notice here like your IPv4. Now let's understand the address scope. What is a scope? So scope is a region where an address can be defined as a unique identifier of an address, means up till where the address is valid. So scope or the regions are in IPv6 are global network, site network, and the link address, or we call it linked local address. So let's first understand about the global unicast address. Number one thing, it is routable and reachable across the internet. Global routing prefix, the, the leftmost like side of the number, the global routing prefix is assigned to a service provider by IANA. So it's globally unique. And then comes the SLA, or the site level aggregator. SLA, or you can also call it a subnet ID, is assigned to the customer by their service provider. Then comes your LAN ID. LAN ID represent individual network within the customer premises or within the customer site, and it is controlled by the customer. You are free to choose your LAN ID. And obviously the last part, the host ID or the interface, is same as 64-bit. So this address is globally unique. Then we have got unique local unicast address. It's something like a private IPs of IPv4, of the range of 10 or 192.168. So they are used for local communication within the LAN or intersite or VPN. They are not routable on the internet. Number 3, the last one, is the link local unicast address. These are mandatory addresses. You have to assign it, and they are used for communication between two IPv6 devices on the same link, and they are automatically assigned by the device as soon as your IPv6 is enabled. And remember, it is not routable, and they are normally identified by the first 10 bits, which is FE80, and the next 54 bit of the network ID can be zeros or it can be manually configured, and the last 64 bit is again the host ID, which is the same. It can be MAC address. So once we have understood this, let's move on to configure a IPv6 address, and it is an important topic from the examination perspective also. So if I show you this, I have got one IPv4 coming up here, right? I've got two machines here. One is our old trusted VT1. So if I show you a IP address show, I've got one address IPv4 coming up, and if you see there, IPv6 is FE80. I just told you, FE80 means it's a linked local address. It is identified by the first 10 bits of linked local address. So FE80 means it is your linked local address. So I can change this. So what I can do, I can create a connection for it. So I'll just create a connection, NMCLI connection show. This is the connection and this is the interface which I have to use. I can copy this. I'll create a connection, NMCLI connection add, give it any name, say IPv6 hyphen test, anything, and type obviously is Ethernet. You can specify it, Ethernet, and interface name will be my address. Oh, sorry, I forgot to give the name, con name. So let's do it again. NMCLI connection add, con name, connection name IPv6 test, type Ethernet, and interface name will be the same name. That this particular interface will be a part of this connection. That's great. So if I show you this NMCLI connection show, it is coming up, but again, as anticipated, I don't have any interface in it. Okay, so let's assign an IP here. So I give NMCLI connection modify. So my connection show is this IPv6 hyphen test. So now I give NMCLI connection modify and my connection name is IPv6 hyphen test, and I give IPv6 dot addresses and the IP address. So I give different IP here. So you will be asked to assign an IPv6 address in the exam also. So just need to replace this number with the number that is given to you in the exam. I'm just using this number. AB1E. That means all zeros. Colon 64/64. It's done. So, and I should be assigning it manual. So the next is NMCLI connection modify IPv6 dot test IPv6 dot method manual. So I had assigned this. Obviously I need to do a like link up and down or down and up. I give NMCLI connection down IPv6 hyphen test, and I give a up here. It's up. So if I show you this IP address show, I think this is the IP address that I had assigned. This link local address is coming up here, which is the identity on the local LAN, as it is starting with FE80. But this we can presume it's a global scope global. See here, scope link. So I should be able to ping this. So ping 6 utility can be used, and I can just try to ping it. Yes, it's reachable. I'm able to assign the IPs and IPv6 address and to ping it. So you have to make sure that you are able to assign a IPv6 address using the NMCLI. This is, again, I'll repeat again, it's an exam objective. So this is all for the day, and in next session we will be understanding about link aggregation, teaming and bridging. I'll see you again soon. Bye bye.